Okay, is it on? Yes, it's on. Wow. Yeah, the second slide with my name on it. So I hope you're ready for yet another one, because I have yet another one. So first things first, hi. I just wanted you to know that I'm a terribly lazy person, like objectively lazy. So that's why this topic, because being a lazy person, I don't like doing things manually. Like, I literally hate it. While I'm a pretty curious person, so if I have a new shiny toy that I can use to, automate some stuff for me, or at least make it a little bit less tedious and more interesting, yeah, I'm all for it. I think my experience in Kubernetes is close to 4 years now, so I think it's enough to get bored as hell with doing stuff manually, even if I wasn't such a lazy person with attentive issues. So without further ado, let's get going about what I want, about the very shiny toy that I want to show to you. So first thing first, because as I said, attentive issues and stuff like that, I prepared you a slide to explain what I want to talk about, so that you not get lost in my bullshit. So first, I'll show you my average day on a cluster without my pretty shiny toy. Then about how to make the cluster your own, or rather the stuff that is on the cluster. Then I will tell you what are the consequences of the fact that I like stuff, whatever that means. Why I don't fear boilerplate no more. And then some stuff about operators, informers, metrics, webhooks, and other very difficult words that are not so difficult in practice, but yeah, just some fancy names. So that's why I use pop song references to make it at least a little bit funnier. OK, so just an average day on a Kubernetes cluster. I have my nodes, I have my pods, I have my containers, my volumens, stuff like that, and lots and lots and lots of communication between them. OK, good, good. So yeah, looking at it, it just works. So whenever you're using the CLI or some kind of visualization tool, you're just having a look at that and doing, sorry, and doing, huh, yeah, I can be proud of myself. That's a pretty beautiful cluster. Well, not really, but yeah, let's say that for the sake of our sanity. But our sanity, is a very fragile thing that can't be bothered by stuff like new versions and updates of stuff. So as I said, I like stuff, but I don't like, doing stuff. So while I like my nodes and my pods and my containers and stuff, I don't like when I need to add some stuff or remove some stuff or change the version of some stuff. I like my stuff to be done already and be there and be shiny and beautiful and entertaining. So what do? OK, I can edit everything manually, but that would be tedious as hell, so I don't do that. So, of course, if that was my first day on Kubernetes cluster, that wouldn't be what I would do, probably. But because it's not, I know that, we have stuff like replica sets. So these pods I can spawn automatically and just, change the number of replicas if I need more and stuff like that. I can have a service defined so that this communication between these containers runs through the service and the virtual AP port, virtual ports and whatnot. Yeah, so you can do that. It's still a little bit tedious because I just showed you here I had more than one thing to do. I had to increase something, decrease something, change the version of something else and stuff like that. But yeah, better than nothing, right? So I can get my, my Helm chart, and inside of this Helm chart, I can prepare yet another version of this Helm chart and just, you know, upload or apply the whole Helm chart to my cluster, and it's all good and fine. Okay. Well, what now? I need to run some commands on my containers, because let's say, yeah, I removed the volume here, but because I did, this node works differently with this node, so I need to run a check between this volume and this container, because their communication depended on this volume, and now it cannot depend on this volume. And when I add some containers here, I need to run some command of all of them to, you know, reconfigure them or whatever, and run some check on the new version of this container to, you know, because we have a new version of container and new version of volume, so we need to check if they are compatible, stuff like that. Yeah, would be bothersome to run that manually. And unfortunately, you can't really run that from a Helm chart, because Helm charts are, you know, the declarations of what you have on your cluster, not what you do on your cluster. And as I said, I like stuff, so I like what I have on my cluster. It's shiny and beautiful. I don't like doing stuff on my cluster, which is exactly this, which is unfortunate. Okay, so what do I do now? Well, Helm charts are just one thing I can do. I could do something that would also add some doing stuff feature to all of this. So let's imagine I would have something that, you know, encompasses all of this, and removing this stuff, updating this and adding this and running all those commands would be, you know, prepackaged. So how would I do that? Well, of course, I need a resource that says that these things are, you know, somehow connected. But it's not standard, right? At least, you know, doesn't look standard to me. It's just some random bullshit that I created. So it's custom, right? It's my own. Well, sort of my own. So how to make it more my own, as it's more customized? Well, first, let's assume, just for the sake of it, that I have even more stuff like that. And why? Because if we do, then we can see what are the variables here. So for instance, here we can see that these nodes that I add containers to, the green ones, in here we have 3, in here we have 1, in here we have 2, but inside we used to have 2 containers, now we have 3 containers. In here we have 2 pods, 1 pod, stuff like that. So these are our variables, right? This can change. It's just to show you examples of how it can look like. But also we can have such multiple groups on the cluster at the same time. That would be even more doing stuff, right? So not going to like that. I don't like doing stuff. I like stuff to be done. So let's make it our own. So let's define all of this with the questions that we asked as a custom resource definition. So let's just call it RPG IBM.com. Like, these are our fighters, this is our mage, this is our druid and bard, because why not? So now we know that we want to customize how many of these folks do we have here, how many pods do we have here in the replica set, how many containers we have here, how many pods we have here, which version of this little fellow is here, how many volumes we have here, and if this guy is present or not. Okay. So that's basically how our RPG party will look like in And in this update, we want to add more spears per fighter in a fighter team. Update the magic book version of our mage. Reduce the druid's domains from 2 to 1, so it's no longer like, let's say, a sea and forest druid is just a plain old boring forest druid, and the bard now only plays one instrument because he's talentless. Okay, well, that looks nicer still. Well, it doesn't do stuff just yet, but hear me out, it will. Okay, so next thing is, here, it doesn't really, it's not really so different from a Helm chart, right? We still have, well, it looks a bit nicer maybe, at least it's more concise, but we still need to change all this stuff here, and we have no history left and whatnot. So first thing first, let's create another custom resource called party upgrade. So now I don't need to do stuff right now. I can simply say, okay, let's get a party upgrade before our next session. So you know you're all leveled up before we start, so that we don't waste time. But you don't have to do it now because we're already on our way to grab some booze or whatever. So thanks to that, it's called reification, which is, you know, change doing stuff into more stuff. So here we had doing stuff, like change from 2 to 3 and stuff like that. And here we simply have stuff, no changes, right? I don't change anything, I simply create more stuff. And this stuff does stuff for me, right? Yeah, I know I overuse the word stuff. But as I said, I like stuff. Okay, so now all we have to do is implement this thing and this thing. Okay, this thing is pretty easy. As I said, it's basically just a Helm chart, functionally at least. Like, this is literally just a replica set. This is even easier. Okay, how to implement this thing? Okay, so we need something on a cluster that will run and see this guy, see that, okay, it's scheduled for, okay, I don't have a watch, it doesn't work, sorry. Okay, it's scheduled for right now, let's say, we're back to the future and it's tomorrow. And it's 12 o'clock and it says, okay, time for an upgrade. And it does the upgrade. Okay, how to do that? Well, of course, it's a cluster. So we have our pods and whatnot, right? On a pod, you can run pretty much whatever you want. So you can run something that looks at this thing and does stuff for us. Like whatever you would do, you simply implement in this thing. Okay. So you could basically implement any program written in any language, right? I mean, you can Dockerize pretty much everything. You could write a program in Java, let's say. Well, Java's not a really good idea, right? Because, you know, you have the JVM and you would need to run it on Docker, which kind of sucks, but yeah, you could do that. You could run Python, you could run Go, whatever you like, really. Okay, but isn't it doing even more stuff? Like, okay, I wanted to simply edit some files in a Helm chart, and now I need to implement a whole program for myself just to do it for me. Hell, I don't like doing stuff. I like the stuff done. This is not stuff done. This is even more stuff to be done. Well, at least it's interesting, but, you know, ideally, I would prefer it to be both interesting and, like, done. So what do we do now? Okay, we can generate it for us, because, you know, these all things are pretty similar, right? We have some resource, we need to read the resource, we need to see that the resource was created or changed or whatever, react to it in some way or manner, and that's pretty much it, yeah? How hard can it be? Of course, somebody wrote a library for that. I mean, programmers are lazy, right? So they want stuff to be done. They don't want to do stuff. So there is this beautiful thing called Kubernetes sample controller, which shows you how to do that, exactly that. Okay, so we enter GitHub, and we look at the hack directory, because you know hack means do some interesting stuff, so we're obviously interested in that. Here we have some boilerplate, which we don't like, because we don't like to do stuff and we don't want to read stuff that is just there. So we go straight up to code generator, right? So we read this stuff and go, okay, doesn't look too big for me. Seems okay, seems fine. Okay, let's look what it generates. Okay, we have the sample controller. Here we have some types, and this thing that is generated, it's called ZZ generated deep copy. Okay, so we can generate the deep copy functionality into our types. Okay, what are these types? These types are basically this thing, but described this time in Go, which is arguably easier and better because we don't have to write YAMLs. We can write Go code, which at least for me is, you know, kind of an upgrade. I would prefer to not use Go either, but you know, if I get the choice, here it is. Well, in here, obviously, we don't have our party yet, but at least it's something. It's some kind of foo with, you know, the spec and state and status. We have some replicas here. That's good. It's exactly what we want with our fighters, right? Some replicas to work with. Here we can list it. Yeah, looks pretty much like what we want to have. Like in the status, we have the currently available number of replicas. Yeah, this can work. This can work. Okay, so basically we have something like this, and there are other files generated based on that, right? In this code can. Yeah, so many files. Anyone confused about the number of files here? Which ones are generated? Which ones are not? Which ones are forward? Well, at least this code is certainly nice. I mean, you can't really write less code for this functionality, really. But the code generation part isn't really my thing, because, you know, lots of code, lots of, well, I said I like stuff, but I don't like stuff that is bothersome and not shiny and beautiful, more like clunky and ugly. So, enter Kubebuilder, the topic of today's talk that saved my sanity. So, when you take a look at how can you generate code for Kubernetes controllers, we have a few tools. One of them is Kubebuilder. The reasons for why I use Kubebuilder are beyond the topic of this talk, but overall, these tools are pretty similar to each other, so it doesn't really matter. Okay, so now I don't need to copy some weird files into some weird hack directory and run them manually and deploy them on the cluster manually, oh gosh, doing even more stuff. Now I simply run Kubebuilder init, and now I have my whole repo initiated. Wow, that was easy. Okay, so it says, let's create an API. Okay. Let's create an API for our party in the RPG group. Okay, it got generated, and it says, let's generate manifests. And you know what generate manifest does? Well, of course, it generates the YAML files for us. So no boilerplate right now. Not using that. It does it for me. So when we take a look at what stuff we have now, we have the API, the commands, some internal stuff with controllers, and of course the hack. But, you know, I've never entered that. I'm pretty sure it's more or less the same as the previous example, but, you know, I didn't have to touch that, so I don't care. Okay, so what can Kubebuilder do for me? Here is our main file. It's all of the main file. Here we have some parsing of command line parameters. Here, this is interesting. it already establishes how to set up metrics and health check for my program. Well, that's useful. I would need to do that, and I would need, oh gosh, I would need to think that I need that before I need that. Or alternatively, I could just bump into it, right? So I implement my program, it runs fine for like 1 second, and then the Docker file, bam, it crashes the container because it doesn't answer health checks. Well, I wouldn't like that, because that would mean doing more stuff. And now the stuff is done for me. It's here, the health checks are added. They are simply pings, and it just works. Yeah, I can already deploy this on the cluster. It doesn't do shit, but you know, it, as we say in Polish language, it doesn't call for food, so I'm happy with that. Okay, and what is here? Here we have the party reconciler. What the hell is a reconciler? Okay, this thing. It says it contains a Kubernetes client. That's good. That means it can do stuff on Kubernetes. And it has the scheme, which means it has this thing. This is the scheme. Okay. So it can do stuff with this thing. Right, okay, that's what I wanted. Okay, so how do I do stuff with my thing? Okay, we have the reconcile function, and that's it. Okay, that was pretty easy. I mean, this file, well, this file might be a bit intimidating, but this file, yeah, super simple. Most of these are like comments explaining to you what the hell's going on. So, yeah, I like that. Not a lot of stuff here. I mean, now I sort of kind of, you know, I'm starting to see the balance. I mean, at the beginning, I had too much stuff to do on the cluster, too much, you know, ops in the DevOps. Then I thought I will have to implement the whole program by myself, which is slightly a bit too dev for me. But this I can do, I think. Okay, so what next? Okay, I need to, you know, do stuff with my stuff. But it will be done automatically. Yeah, that's good. Okay, so I will not have to do stuff like on my own. Okay, how to do that? We need to communicate with the Kubernetes cluster. Well, we could use Kubernetes API, but that's not really good because, you know, lots of traffic and stuff like that. And also, the problem is we can't really observe that something is created. We would need to list it all the time. That's not good. Okay, so we have this notion in this sample, once again, sample control. We have this thing called informer. I hardly know that. Okay, okay. What's an informer? Okay, informer is something that informs you that something is done with something. Okay, so more doing stuff. I don't like doing stuff, as you know already. You're probably fed up with that phrase already. Okay, so this is the main in the sample controller. Not really much bigger than in Kubebuilder, right? But here I have so many chain stuff, and this here is my controller, yeah? Much bigger than the other one. What are those things? Okay, those are these informers. But why? Why do I need so many informers? Oh, right. Because I have 2 stuff on my cluster. So I need an informer for each one of them. And if I had 3, I would need 3 informers because, you know, an informer is separate for every piece of stuff. Well, me not like. Especially considering that this code, okay, is generated, but reading through this stuff gives me physical pain. Too much code to implement this informer thing. Not like, I don't like this ugly stuff. I want beautiful, shiny stuff that does everything and, you know, is perfect and not clunky and hundreds of lines. Okay, Kubebuilder, please surprise me. Do something spectacular, okay? Please do. Okay, this whole code does the same. Huh. Okay, I can do with that, yeah. That's just enough dev for me, right? If I write 2 lines here to you know, get my stuff, and then add 3 lines here to, you know, set the work queue so that the stuff gets done in parallel, like 1, 2, 3, 4 stuff at the same time. Yeah, that's about right. That's enough code for me. It fits so nicely on the slide, doesn't it? Yeah, that's enough dev for me. And also it does stuff. I like that very much. It even logs the party for me. Nice. So why is it so much simpler? Well, you see, the informer is a thing that takes an event, takes its previous state and its next state. And an operator, a Kubebuilder, a reconciler, so to speak, doesn't do that. It ignores the event. It simply sees the new stuff and takes the stuff and operates on stuff. Okay, but why is it better? Well, you know, because if something breaks and your program simply has to restart, it will drop events inevitably. If events happen during the time where your program is not responsive, well, you're not getting your stuff done because you don't know that you should. But for the reconciler, it doesn't matter. It simply checks periodically whenever it needs to do some stuff with my stuff or not. And also checks if something changes on the cluster and stuff like that. But, you know, it doesn't really care what happened. What it cares for is that it's not perfect, which is pretty much what I would do. I mean, what I care about is that my cluster is not perfect, not why. I mean, ideally, I would just not bother debugging, right? If I can simply remove the bug, I don't need to know what the bug was. I just want it to be shiny and beautiful. Okay, so Kubebuilder, not only I have less code, but I also don't really care what happens. I only care about my stuff. Finally, my stuff, as I said, I love my stuff. So I operate directly on stuff. I'm happy. Okay, Kubebuilder, let's get some stuff to be shown in an attractive and interesting way so that I can show it to my colleagues that aren't so fond of stuff. Like developers that don't really know how to write this thing or whatever. Or my manager, that would be awesome to show them that the cluster works perfect and I can show it to you. So as I showed you before, showing your manager the nodes on your cluster and, hey, manager, look how nicely they, you know, talk to each other and get to know and make friends and find love and whatever. Well, it doesn't really work for managers, does it? Well, you can use this beautiful thing in Kubebuilder. I haven't really found you know, the analog in sample controller. It's not that in the repo. I'm pretty sure you can do it somehow, but I don't really care now that I have Kubebuilder, right? You can use metrics for that. So the metrics will be some values that you can pass around in your controller, in your operator, and that will show you, you know, some numerical values assigned to the stuff that is happening. So once again, we're changing doing things with stuff into actual stuff. Like, we don't care about how the party changes over time. We only care about what the size the party is. So how many fighters does it have? Because, you know, everybody needs a fighter in our party. I know you do want someone to protect you. So, okay, we are interested in the party size. So here, we show it. And here, we set it so that we can show it later. Okay, that's not too much code either. And considering that quite a lot of it is just, you know, configuration like, what is the name of your metric? And what is the help message that is only useful for humans? So not really useful at all most of the time. Yeah, fits nicely on the slide, so that's good. That means I haven't done too much doing stuff. So I'm not unhappy either. And now, if you go to the metrics, as I mentioned, I didn't set this thing. It was set for me by Kubebuilder. I simply added some metrics to it. Even if I didn't, I would see this thing, which basically measures how many errors I got from my program. See, I didn't need to think about that even. It simply does stuff for me. That's great. And now I also have some metrics about the party sizes. So now I don't even have to enter my cluster to see how perfect the stuff is. So I can see that the Shire team contains 4 hobbits and the Aragorn's team contains 9 people of various ancestries. Yeah, that's great. And I don't even have to show my manager the nodes and pods and tell them about all the ugly stuff that happens in there, like orcs attacking or whatever. Well, that's nice. Okay, but I can see a problem here, right? I'm not sure if you've noticed it also. So the Shire team contains 4 people, but the Rogue and Roll team contains only 3 people. But I've mentioned that we need a mage, a bard, a druid, and like 1 or more fighters. Okay, but that's already 4 people. So why the hell is this 3 people? It means they lack fighters, like they desperately need fighters. Why was it even allowed? That's not what was supposed to happen. Ideally, I shouldn't even have such a situation in my cluster because it's not perfect and shiny and beautiful. And I want this stuff to be perfect right now. So one of the solutions to that is disallowing registering adventuring parties that don't have a fighter in them, right? Okay. Easier said than done. How do I do that? Well, normally, I would need to do even more stuff on my cluster, like register a webhook. So when I add my custom resource, the webhook would activate, and this webhook would disallow any party that doesn't have any fighters in it. Okay, but as you know already, I don't like doing stuff, so I won't do webhooks on my own. I refuse to do that because it's too much work. Okay, Kubebuilder, I hope you have it covered. Of course you do, of course you do. You have everything covered, my dear sweet Kubebuilder. Okay, so just like we created an API for our party, we also have similar command for webhooks. So we have a webhook for party, which will be programmatic validation, which means we can write pretty much any Go code that we want. We can pick some other types of validations, but that's fine for us for now. Okay, we can see that it runs successfully and says, implement your new webhook and generates manifests. Okay, manifests we can do. We take a look at the API, and here we have the party webhook. Right, okay. We have the very similar to the controller part of code. We're not interested in this. And here we have the default. Well, not really interested in default because no party is the same. And here we have the validate created that can return an error or warnings. Validate update and validate delete. Okay, so question. I said that Kubebuilder doesn't really care about doing stuff. It only cares about stuff. So why do we care about what stuff is done right now? Well, obviously because it comes from webhooks and not from Kubebuilder. So it's not Kubebuilder fault. But really, you can still sort of kind of ignore what is being done, right? So you can simply disallow creating and updating for the new thing, for the new party, disregarding the old one. But you can also forbid, like, downgrading your magic book because no one likes to downgrade stuff or whatnot, whatever. Okay. So we have all of this beautiful code generated in like 5 minutes or so. Okay, not sure how long I've been talking. Maybe it's 20 minutes or 30. Okay, but nevertheless, it's quite fast, right? Now, how do I run it? Well, if it was the sample controller, I would simply get the YAML files that I would need to apply to the cluster and probably make some pipeline like Jenkins pipeline or GitHub action or whatever to do it for me periodically or whatnot. Maybe implement some makefile. Luckily for me, Kubebuilder has it covered. It has a makefile. As you saw, make manifest, right? It also has make deploy, so nothing to show here. I just run make deploy and I have it on my cluster. Yeah, and my party works now. Like the updates just do themselves right now. I only need to add some stuff planned for later. So when the party levels up, I simply create a party update scheduled for before the next session, and the party levels up by itself. So why is Kubebuilder made for DevOps, and why does it, make the DevOps again? Like not dev nor ops, just DevOps. Because you can start immediately, as you saw, because you simply run a few trivial commands and you're done pretty much. You can either even deploy it on a cluster straight away and everything just works. No informers needed. You just write like 2 lines of code with reconciler get me party. That's all you say. You don't have the work queue because you simply said, okay, reconciler, now you have 2 workers, that's all. You have metrics already plugged in, right? You only need to add your particular metrics that you're interested in, but no boilerplate for that. You have easy webhooks because you have simply one command that generates you the very minimalistic template for webhooks. Again, no boilerplate, just a template for you to fill in. And easy deployment because you simply run make deploy and it works. Nothing to show here, really. And now I can focus on stuff. And I don't need to do anything. I simply add more stuff to my cluster and I'm happy now. So if Kubebuilder makes me happy, maybe it will make you happy also. I hope so. Thank you. And thank you, Kubebuilder authors.